we're going to now do operators in C++. Operators are really cool stuff. Basically, if you have a class, you can't do any of the standard operations that you can do on like an integer, right? On an integer, you have integer x is equal to 10, and we've got y is equal to 20. So we could say like x is equal to x plus y. Y is an operator. X is equal to x minus y. Minus is an operator. You cannot do that with a class. For example, if I have this class vec here, if I make vec x and vec y, I can't subtract them from each other. It doesn't even make sense to subtract one vector from another vector, right? And so can I add them together? No. Can I don't know, multiply them? No. Can I divide them? No. So by default, not a single operation, plus, minus, square bracket, none of these things will work on a class, a custom class that you guys make. But you can add one. Do you guys remember this for string? So you can have string str1 equals hello, and str2 is equal to world. And you can see out str1 plus str2. Do you guys know what that's going to print? Anyone want to guess? Hello world. Now you might be like, but that's kind of weird. Like, you know, these are a string is actually a custom class. It's not a built-in thing in C++. And so what they've done is they've added a plus operator for strings. There's no minus operator. I don't think you can subtract one string from another. That doesn't work. You can't multiply them. You can't divide them. No, none of that works. But you can add them because it makes sense. Like, it kind of intuitively, it makes sense to be able to add one string to one string, and everyone's fine with that. So we've got up here, we've got our, let me delete that. Okay. So here we've got a very basic vector class. And this vector class just has on the back end 100 hard-coded, array. And we've got an at operator on it, right? So this will allow us to do things like, say, vector Bob. And we say bob.at 10 is equal to 420. See out bob.at 10. Just like that. Anyone want to guess what that is going to print to the screen? The at function is the same one that I gave you guys before. Does a little bounds checking. I've hard-coded 100 on here. It's horrible coding style. But I don't care. We're doing this in like 10 minutes. So what happened if you tried dividing a string? I don't know. You're going to like split an atom or something. Have a nuclear holocaust. Yeah, it's going to print 420. Right, because this .at thing here is just returning a reference to the internal array that it's got. Get pull. CC. 420. Okay. So, do you guys remember on the standard vector class that there is not only .at, you can say vector of integers Bob, size 100. Look, you just replace it with a standard library, and it'll run the same way. But the vector class doesn't just have .at, it has square bracket. So you can actually have square bracket. And that's an operator, and it works. So how do we do the same thing for our class? Well, anytime you have an operator, you see here, it doesn't like us anymore, right? It doesn't like the fact that we're trying to do square bracket on Bob because it doesn't know how to do it. Anytime you do an operator like plus, minus, square bracket, any of these things, you have to tell C++ what you mean by square bracket 5 or whatever. Okay, and so this is actually going to be very similar to .at, but if you guys remember how square bracket works in the vector class, it does no bounds checking, right? And we're also throwing an integer. It's so terrible. It's terrible. Forget about it. Don't worry about that. Okay, So instead of .at, the name of this function is going to be operator square bracket. That's it. And now we're cooking with gas. So now we can access element 10 with bounds checking here. We can access element 10 without bounds checking here. Compile the code, run it, we get 420. Okay. So what this is doing here is this is telling us what we mean whenever you see square brackets attached to our vec. We're making a vector class. Anytime you see a vector class with square brackets on it, it basically says, okay, return, we're passing in a parameter, passing in 10 here. So it's going to return a reference to array square bracket 10. And a reference means it's not returning a copy of the value, it's actually returning a pointer under the hood to that guy that we can treat like a regular variable. So we can see out, we can set it, we can set the value, we can print the value, and that works because this is a reference we're returning here. Okay, what other kind of operators can we do? Let me show you something kind of horrific. The Java language actually removed operators from C++ because people were abusing them so badly. But the standard library people love this one trick. Doctors hate it. But the standard library people love this operator, and it is called operator parentheses. And operator parentheses would allow us to do things like this, with smooth brackets instead of square brackets. Very similar. But this isn't compiling because we need to tell it what parameters it takes, and it's going to take no parameters. Look at this. Look at this. Isn't this amazing? Isn't that a cool syntax? I think it is. I think it's amazing. So we are making, so we're going to say what happens if we call Bob like it's a function. Look at that. Bob's not a function. Bob is a variable. But because we have the function operator defined on it, we can pretend that Bob's a function. This is something called a functor. Okay, so this is called a functor. Friday night functors. Okay, and we need to do something, so we can just like return, I don't know, 100. And so when we call Bob as if it was a function, it'll call this guy here. It'll call the function operator overload, and it's always going to return 100. You guys like that? Do you like it? No? We can make it do something more fun. We can have it do accumulate, something like that. Why would you do that? Great question. The standard library actually encourages people to do this. That's the scary thing. Right? So let's put a couple more values in here. So, I don't know, make that 720. I don't know. And so when we call Bob now, it's going to add up all of the elements inside of Bob and return the sum. Okay? So if we call Bob like a function, it should return 1140, right? Good. So if we call Bob like a function, it's going to add up all of these elements that we've put into Bob, wherever they are. Element 2 is equal to 3. I don't know. I'm running out of ideas here. So that'll return 1143. You guys see that? So why would you use this? Why? This looks like a function call. And you can make it take parameters too. Like we could have it take an integer, x, and return like, x plus accumulate or something like that. I don't know. And then we can put in like 10,000 here or something like that. I don't know. Running out of ideas. There we go. 10,000 plus 1143s. Why would you do this? Why would you do this? Well, as it turns out, if your thing has the function operator overload on it, you can actually pass it to something that requires a function. So do you guys remember sort? Sort has, if you're going to sort a vector, right? You got like vector of integers named, vec. And we already got a vec. Dang it. Great, cool, whatever. Yeah, we're sorting, right? We're sorting. Do you guys remember this? Sort, right? We're sorting. Check this out. Watch this. Okay, so see out Bob passing in 10 and 5. Okay, so, and we'll just quit for now, I guess. So, true or false? Is 10 bigger than 5? Yeah, it is. So Bob here can be passed as a third parameter to sort. Let's fill vec with something a little bit more interesting. Let's make n a little bit smaller so that we don't print a million elements. You guys know what iota does? It's going to fill it with the numbers 0, 1, 2, 3, 4, 5. Iota is in algorithm. It's not algorithm. Numeric? I thought it included numeric. Okay, let's give a starting number. Okay, so the first number in the vector is going to be 10, then 11, then 12, then 13. Okay. And so, if we, for every integer in the vector, see out that integer, let's even make n smaller. Let's just make it like 5, whatever. Okay. So we're going to print out all of the elements in the vector, and then we're going to add them all up. Get rid of that. We're going to add a couple zeros. Let's add a 100 and a negative 100 to it. Order 1 now. Okay. So after we sort it, we are going to then print out the vector again. So we're gonna start off with the vector containing 10, 11, 12, 13, 14. We're going to add 100 and negative 100 to it. And then we're going to sort it and print it again. So look, here is our original array, 10, 11, 12, 13, 14. And we then add 100 and negative 100, and then we sort it from greatest to smallest using Bob. What? How did Bob? Where did this guy come in? What the heck is that doing? Bob, because he has the function operator overload on him, you can pass him to anything that expects a function. So it's a class that can be passed as a function because it has a function overload. And so up here, the sort is going to call over and over again, hey, compare this guy and this guy, and return true, whichever one's smaller. And I'm doing the opposite. Instead of returning which one's smaller, I'm returning which one's bigger. And so that forces sort to actually sort it greatest to smallest. instead of smallest to greatest. So by making a functor like this, we can do a quick greatest to smallest sort, or we can make custom sort algorithms however we want. So this is just one of many uses of functors. A lot of people hate them. If you go onto the chat channel and ask Voss and Megan and things like that if they like functors, they will probably say no, they don't. But this is you will see this all the time in the standard library. Operator parentheses allows your class to be treated like a function. And there's plenty of other operators out there. If you want to be able to add two vectors together, you can do like vector, I don't know, plus equals, I don't know. So I don't know what should happen if you add two vectors together. Like if you have vector Bob and vector Sydney, what would happen if you said like Bob plus equals Sydney? Like, what does that even mean? Like, you know what I mean? It only takes one parameter. So what does it even mean to add one vector to another vector? What do you guys think? What should it do? Add all the elements together? Append all the elements from one to another? I don't know. Yeah, let's say we're going to add all of the elements in one vector to another vector. So we could say for I equals 0, I is less than 100, I plus plus, r square bracket I plus equals a dot r square bracket I. So we'll take all of the elements in Sydney and add them all to all of the elements in Bob. And then we could write this code. We now have defined plus equals on a vector. And you can say Bob plus equals vector Sydney. And it'll do it because it knows how to do it now. So any single operator you can think of, plus, minus, multiply, square bracket, parentheses, star for pointer dereference, all these things can be overloaded. There's only a few exceptions where you can't overload something. And then you can have it do whatever you want. Just be careful with it because a lot of people take operators too far and they do weird things. A friend of mine made a database where plus would like insert into the database and minus would delete from the database and double equals would search the database. And he was very proud of it, but his code was like unreadable. Like you had no idea what was happening. You would look at all this algebra. It's like x plus y minus z. And you're like, oh, you're doing algebra. And you're like, no, these are SQL databases that's inserting and deleting things from the database tables. And you're like, what? It's horrible. So increases the capacity and adds values. It probably should. Yeah, it could append all the elements from one to another on it. It's really fun if you understand it, but if you don't, yeah. So don't abuse operators. Like Java got rid of them for a reason, because people could not be trusted with the power of operators. But things like this, like you have to have them in order for a vector to be able to have square bracket 5. Like in order for that to work, you have to be able to overload the square bracket operator. And in Java, you can't. If you make your own vector class, you can't have it work with square bracket. It just won't work because you're not allowed to overload those things. You can't overload any operators in Java. You have to just make a function called .at or something like that. Okay, so they're great. They're awesome. Try to use them in moderation, and you'll have a good time. And with that, I bid you all adieu. Have a wonderful day, everyone. Say goodbye to everybody.